Hello, and welcome to Exam 1 review. So, yeah, in your infinite wisdom, you want to have an exam. So what's on it? Why is this blue? Chapters 1 and 2. About 70 to 80% of the problems are in chapter 2, which are limits and continuity, and then some questions pertaining, hopefully, inverse and stuff like that. So, what do we have? Number 1, definition of a function, of the function. What else is there? Function composition. Remember the difference quotient, right? Inverse function. Graphing basic functions. You have the list in your notes. X cubed, square root of x, ln x, e to the 3x. So that's, and all of this stuff is chapter 1. Find limits, and that breaks down into few of the categories: graphs, charts, plug-in, algebra. So all different ways that you learned the first two, 2.2, next two, 2.3. Number 6, infinite limits. Plus vertical asymptotes, that's your 2.4. Number 7, limits at infinity plus horizontal asymptotes, that's your 2.5. Number 8, continuity, which is 2.6. Now continuity has those rules, 3 rules. Global, and then those 2 theorems, so that you can show that something more complicated is continuous by looking at it. We did a few of those as well. Number 9, we can toss in some of the, let's say, squeeze theorem or sandwich theorem, right? That's a good one. And I think that's it. I'll put maybe. Or could show as a, like a part B or part C or whatever of a question.
Perfect.
What happened?
You're saying just identifying the output for a given input?
That's chapter 1. That's a function. So you're looking at 10 problems, and some might have parts, function definition that's given to you the first day in red with those 4 underlined words, right? What else is there? To find the inverse, right? You swap x and y and you compute. Yes? Yes. Well, that's the reason why the first exam weighs less. Because you guys are not used to theoretical questions. State the definition, state the theorem. You're not used to stating the formulas because pretty much all of the mathematics you covered so far was monkey sees, monkey do, right? And this is the first course where if you don't know theorems and definitions, you are just wasting your time, because if you memorize the way to do the problem using polynomials, but then there is exponential function involved, you have no clue what to do. So knowing definitions and theorems is crucial for success in calculus, which is why definitions and theorems are also questions. Part A, state the definition of a function. Part B, compute the value for this function. Or what's the domain of 1 over x? And you go, aha. The only value that I can't have is 0, so domain is from negative infinity to 0, union 0 to positive infinity. So those are types of questions that, are there, and as you can see, the first part of that. What are other theoretical questions that you might run into? The huge limit theorem, right? If the left and right limits are the same, overall limit exists. If they are not the same, limit doesn't exist. That was huge. 3 rules of continuity, right? Function value exists, limit exists, they are the same value. Again, that could be a question. You have 2 formulas for vertical and horizontal asymptote in terms of a limit. It's a formula, right? Stating that the vertical asymptote is given by limit x goes to some value a of f of x equals positive or negative infinity. Vertical asymptote is at x equals a in that case. Right? That's a formula. So that's the theoretical part. If it says state the formula, well, this is what you're writing. No need for essay of what the vertical asymptote is. We all understand what it is from this formula. So some of the questions are theoretical, some of the questions are calculations. The only thing that we are not going to have to the large extent is the, I forgot the precise definition. See what you made me do? Generate space. 10, 2.7, precise definition of the limit. The epsilon delta, right? So we are not doing proofs. It's not an honors option. The only proof you might encounter on this exam is to prove that something is continuous by using those 2 continuity theorem like we did in class. Other than that, you are not going to have any other proofs on this exam. Now, if you're interested in proofs, we'll talk, or you sign up for the honors option, which has all of the proofs in it. That's mainly for math majors, electrical engineering, right? People that will be heavily utilizing math. So that's the exam. It's hour 20, hour 25 to solve the exam. I do something very interesting, which is I allow, well, this classroom has 29. So on a group of 29, I allow 8 questions. That's it. So if you come up 8 times, then you just killed all of the questions for everyone else. Yeah. And I think that's it. No graphing calculators. Bathroom, you go before the test and after the test, unless you have accommodation with a medical thing attached. But I know no one has it because I haven't seen anyone running every 5 seconds during the lecture. No cell phones, no tablets, no computers. All right. Any other questions, concerns? Yes. 10. It's easy to grade.
So the exam's going to be on some kind of paper and that?
Yes.
Okay.
So I've asked a question about
Anything you have.
The actual question.
Yes.
I emailed you the problem, if that would be easier for you.
Nice.
But I could also show you whatever you want.
Let's check. You did not email it today.
Yeah, I emailed it around 4. So I think,
Today?
yeah. Maybe it didn't send that.
No.
Okay.
I have Christine and Patty. And you're not Christine or Patty.
Yeah. I'll check.
Or you can tell me now.
There's this question with it was like,
Question with calculus in it.
yeah, it was limits. You want to walk up and show you?
Okay, sure. I'll copy the problem and then we're going to. So we have a limit question.
So is this one if I got 10 over someone, and that said, sorry, I didn't get the whole thing, but then it said conjecture about, shoot, you know, like what that would say?
Yeah, just to, so this one is 2, this one is 3, this one is 4. And it's just
like find the values of it or something.
coefficient. Yeah, that's too technical. Questions, math questions. What do you have? Yes.
Can I just read it out to you?
Sure.
So find the following limit as the limit as x goes to infinity, 20x squared plus 3x plus 1, and then that's over 1 big radical of 16x to the 4 plus 2x cubed. I just want to know you just do it for me.
Sure.
Thanks.
You sure this is? So this is one of those limits at infinity. And can anyone help me with this? I'm supposed to divide by the x of the highest degree. And in this case, that would be x to the squared. Good. So why is it the highest degree squared? Because if you take the square root of the 4, you get 2. So the highest degree is 2. So we are going to divide each one of these by x squared, and then divide the entire denominator by x squared. when I divide everywhere by x squared, I have 20 plus 3 over x plus 1 over x squared divided by the square root of, and now this becomes 16x to the 4 over x to the 4 plus 2x cubed over x to the 4.
So we wouldn't be dividing this by x squared? Is that because it's over in the radical? It would end up being x squared?
It's x squared, and then when it goes under the radical, it becomes x to the 4th.
Yes.
So now, we have limit 20 plus 3 over x plus 1 over x squared divided by the square root of 16 plus 2 over x. So when we cancel everything, this is what we have. Now, when you divide by infinity, when you divide a number by infinity, it goes to 0. We talked about it, right? You take one piece of paper and divide it infinitely many times, which means you are cutting it infinitely many times. So each one of these goes to 0, and we are left with 20 divided by square root of 16, which is 5. Yes.
With this same, limit x to say,
If the same equation,
like if you have limit x to 3 instead of 3.
but where do you want that 3? Where do you want a cube? You want it here?
No.
No? You want it here?
I think she means like the limit as x approaches
Right.
3.
Yeah.
Oh, no, you just plug in,
Oh,
right? Because this is the method when it goes to infinity. If it goes to 3, you plug in 3 and you solve it. And if you get 0 in denominator, then you have to massage it with algebra. Maybe you have to factor, maybe you have to write, you'll have to do something. Find it and we will. Any other questions while she's looking for the problem?
This was a good example. I was having some problems with this stuff as well, trying to use algebraic functions to find the value of the limit.
So do you have the problem?
So I believe I had something here back in my notes. Just a moment.
All right, now I'm here.
I actually have something that's more pressing. I'm having trouble with writing some forms in integral notations.
What do you mean?
Writing out the domain of a function. Example, just continuously.
Okay, so what is the function that you're looking at?
The specific example is from problem 1.1.50. See if I can find that in here.
You can find it in the study plan if you go to one. You say 1.1.
Yes.
Okay, so 1.1, and then there will be 50 there on the list.
Yes. Oh, here it is. Evaluating positive functions. I was having trouble. The first part is just trying to determine the composite function, and the next part is trying to find the domain.
Okay, but I need functions. So what are the functions?
But x equal absolute is f times g times uppercase G x, where f of x equals what begins with 1 over x minus 8.
So f of x is 1 over,
No, f of x is absolute x.
f of x is absolute x.
Yes, they're
And what's g of x?
combined function. G of x is x squared minus 4.
X squared minus 4.
Yes.
Okay. And we are supposed to find
And then there's a
function composition.
another function called with uppercase G of x.
And what's that one?
1 over x minus 8.
Okay.
Also find the combination of f of g of uppercase G of x.
F of g of uppercase g of x, like this.
Yes.
Oh, perfect. This means that the function g is going to replace this x here, and then the entire thing combined is going to replace x in there. So to achieve that, we are going to start by 1 over x minus 8 squared minus 4. So this is my capital G plugged into lowercase g. And now all of that needs to replace x, so we're just going to put the absolute value on it. And this is our f composed with g composed with capital G. So now we square this. We get 1 over x squared minus 16x plus 64. We have minus 4. And now, using the common denominator, x squared minus 16x plus 64, 1 minus 4 times x squared minus 16x plus 64 to sort out the numerator. Now we need to multiply all of this I mean, we could have argued from here without multiplying it all out, because you see that the only problem point is
Oh yes, the answer
8.
The answer you have here is fine. It was accepted. The problem I had was finding the domain of the function.
Yeah. So now, if we are looking at so you can do this or not, it doesn't matter for this to expand it, because we can make all of the arguments from here.
Well, obviously, it seems that x cannot equal 8.
Good.
Otherwise, that fraction would be undefined.
Perfect. So,
Aside from that, it looks like the rest of the domain will extend from negative infinity to infinity.
good.
So it's just that one point at 8 that breaks its global continuity. How do I account for that when I write out the domain?
There it is.
Right. I thought I'd seen that, but skipped my mind.
So you have negative infinity to 8, and then you break it at 8, and then you continue with the second part after 8.
All right. Let's ice that value in there. Thank you.
You're welcome. What happened? When? Oh, yes, Victoria. Hi. the question is about slant asymptote, also known as oblique asymptote. And questions like this, asymptotes like this occur only in one case. If you have P of x divided by Q of x, both polynomials, such that you have x to the p divided by x to the q. Those are the leading terms. One for numerator, one for denominator. So slant asymptote happens only when p is equal to q plus 1. So when the degree in the numerator is by 1 larger than degree on the denominator. And to find it, we use the polynomial division. So the problem says, how about this? Find all asymptotes for f of x equals x squared minus 4x plus 7 divided by 3x minus 4. We have 3 types of asymptotes. Vertical asymptote, we set the denominator equal to 0. We get x equals 4/3. And since this does not factor or cancel, we know it's an asymptote, because if any cancellation was involved, you would have open circle, not an asymptote. So vertical asymptote is at 4/3. Horizontal asymptote, you can do the limit, x goes to infinity, of x squared minus 4x plus 7 divided by 3x minus 4. You would get infinity because the exponent in the numerator is larger, which means no horizontal asymptote at all. And finally, slant asymptote is yes, because degree is 2 and degree is 1, and they are, I'll write it in blood, degrees are off by 1. So now I can divide 3x minus 4 into x squared minus 4x plus 7 to reveal the asymptote. So 3x goes into x squared, right? 3x goes into x squared. You're doing this basic division. Goes x over 3 times. So x over 3. When you multiply it back, you get x squared minus 4x cubed, and then you subtract. These cancel, and you have to now work out negative 4x plus 4/3 of x. A little bit annoying, but doable. Over 1 is going to be negative 12 over 3x plus 4 over 3x, has a total of negative 8 over 3x plus 7. You drop that next value down. So now we need to divide 3x into negative 8x, negative 8/3. X divided by 3x, x's cancel, and you get negative 8/9 when you do your double fraction. So negative 8/9. Now that is already linear line. We don't care about the remainder. We don't care about anything else. This is it. So your y equals 1/3 x minus 8/9 is the slant asymptote that you were looking. It's a linear line. It always has to be a linear line, which is why the requirement is that the degrees are off by 1. Because when they are off by 1, when you divide it, you're going to get linear line, x to the first power. Slant asymptotes are those like curved. They're not curved, they're slanted, straight lines. So if you are to graph these asymptotes, this is almost 1. Let's say negative 8/9 is, let's say, right here. And then we need to go 1 unit up and 3 units over. And this would be the slant asymptote. So that's the slant asymptote. And then at 3/4 or 4/3, what was it? 4/3. At 4/3 we have vertical asymptote. Now 4/3 is, if this is 1, 4/3 would be somewhere over here.
I'm having some trouble keeping up with all of this.
And that's it. So you have the asymptotes. So this question was to find all asymptotes. There are 3 types of asymptotes: horizontal, vertical, and slant. Slant asymptote is the one that you learned in pre-calculus, where you divide, use the polynomial division to divide and get the value, right, which is the equation for the asymptote. So vertical asymptote, we set denominator equal to 0 because it didn't cancel. I mean, I know because I look at this and it's not factorable, so it's not going to cancel with 3x minus 4. Since it doesn't cancel, we have the vertical asymptote. If it does cancel, then you can have an open circle, so you have to be careful there. We did the calculus proof to show that there is no horizontal asymptote by working out the limit definition. And for slant asymptote, it's not a calculus question, it's a pre-calculus question to do the long division of polynomials any way you know. And once you get the line, that line is your slant asymptote. And now the functions will bend around these asymptotes. They might go like this. That's a possibility. Now we will discover this in chapter 4. Or they're going to go like this. In rare cases, they can go like that as well. So the goal is not to graph these because, as I said, we are going to have a whole section, 4.3 or 4, where we are going to graph functions by hand. And this problem is going to be one of the 13 parts to find, right? So 3 asymptotes will be 3 out of 13 different things. We need x-intercept, y-intercept, derivatives, and all these kind of things. And 3 out of those, the shopping list of 13, 3 of those will be these 3 asymptotes. So this whole problem now that you are reviewing as pre-calc or Calc1, because we learned the definition for vertical and horizontal using limits, is going to be again brought back in chapter 4. So that's the slant asymptote, or oblique, depending on what the wording, right? Some books say slant, some books say oblique. It's the same thing. Just a linear line at some slope.
So this is the only kind of equation where there will be one value that will have to be counted out of the domain.
That's for vertical asymptote. 4/3. 4/3 has to be thrown out of the domain. Any other questions, concerns? Yes? So, limit x goes to infinity of sine 12x over x. All right, so this question is do what? Well, it's actually 12. So if you have sine x, right, it counts as a 1, but the 12 over here is an issue because you can use trig identities to break this down all the way to what the numbers are. Because see, sine of 2x is 2 sine x cosine x, right? If you have sine 4x, well, there will be 2 sine 2x cosine 2x, and then you have another sine of 2x, which would make it into a 4 sine x cosine 2x. So you see how this 4 ended up outside, and you have a lot of other junk at the end anyway, right? So that being said, this 12, going through iterations of this, will eventually pop outside, divided by 1, so it will be 12 over 1. Now, this is not a fair question right now, because in chapter 4, we are going to learn a technique that is going to deal with this question in about 2 seconds. It's going to be called L'Hopital's rule. I believe it's 4.7 or 4.8. Now that's in 2 weeks for you guys. So I wouldn't concern myself a lot with these questions, because right now these questions are unnecessarily annoying, because you have to employ these trig identities and suffer for no reason, right? We are going to cover this technique in about 2.5 weeks, and you will be able just to look at this problem and know it's 12 without writing anything down, because it's a really cool way to take limits. So I wouldn't break my head with problems that look like this. Yes? How would you use the squeeze theorem for this? Because you can't get the 12 out of it, right? The problem with the 12 makes the sign oscillate very fast. That's all it does, right? So we can define, but see, the problem is that you are going to have 1 over x and 1 over x, and that at infinity, that's 0. It's just, it doesn't work. Squeeze theorem works at the point, right? Because you can't squeeze something in infinity, because this thing is, the sign 12x is bounded by -1 and +1, and at infinity you don't know which one of those, or all of them in between, right?
I got a problem that's similar to that. It's sent to use the squeeze theorem.
There's something on the lab. There's no quote. That's what I remember here.
You didn't write what x goes to infinity?
Yeah. Because I guess it just automatically went to 0, so it's just.
It's going to be 13/6. It's going to be 13/6 there. Now we'll deal with these crazier problems later. Can we use? Yeah, we can use, but any other questions, concerns? So, reading the graphs, making sure that you know that the limit is represented by the y value. Limit can be finite, limit can be infinite. Your x could go to a number from left and a right, can go to a number from both sides at the same time, can go to positive or negative infinity. We have end behavior of a function, right? Goes to positive infinity, negative infinity, and all that good stuff. Just make sure that you know statements, right? We said what could show up on a test as a question. Definition for the limit using epsilon delta. Those two pictures that were in a lecture, you have that posted.
Of course.
And then definition of a function, the theorem for the left and the right for the limits, two formulas for asymptotes that involve limits, three rules for continuity, and then the theorem for global continuity, theorem for the list of functions that are globally continuous, polynomial, sine, cosine, exponential, logarithmic, right? We said all of those. And then finally, the theorem that says that combination of continuous functions or composition of continuous functions is also continuous function, so that you can do those basic proofs that you guys will need in Calculus 2. So I stress those for that reason. I was going to get rid of this so it's not bothering you. I will post this, and I will see you tomorrow. Make sure you don't miss it, because the syllabus clearly says no makeup regardless of the reason.
I don't know if I'm having such a brain fart, but